Hello friends, in this video we are going to learn how to read the schematic diagram. In last video we understood how the A section works, that means how the battery charging section work, and we explained the different signal, their signal flow, and the different MOSFET, their function, the battery charging chips. And in this video we are going to understand the schematic diagram, how to test the point, where are all the signals. Okay, so here on the screen we are open this LAG 711P models. Okay, so this diagram is total 101 page, and we are going to learn only A section, that means the battery charging section. Okay, so first we have to find where this section. So first thing, we'll open this page. This page is basically a block diagram for this entire laptop. Okay, I'll just zoom out this page, and we can see here the CPU is called Intel CPU, is a Whiskey Lake or the Cannon Lake. Okay, and this is the BGA 1528 balls, and these are the different things are connected, like this is a ADP connector, then HDMI connectors, USB, then graphics, then this RTC audio, then here's the SIO, SMSC, KVC. Okay, so different components are connected to the CPU. This is a single chips, like on the 4th generation onwards, everything is on the CPU. So it's a CPU, it's called the SOC. SOC means system on chips. That means everything within the CPU only. Okay, so now what we have to do is we have to find where is our A section, that means our battery charging section. So this entire diagram is somewhere around 101 page. So we'll find where is our battery charging section. The power section is normally the last 10-15 pages. So this diagram is 101 page. That means the power section start maybe after 60 page. So I'll type here 60 and I'll go on page number 60. Here is a reserve. So I continue. I'll continue. Next page, next page, next page, next page, next page. Okay, I'll stop when my adapter connector is there. So this is my DC adapter. So this is my DC. I'll just zoom this pictures. Okay, so this is a DC jack, is written a PJP DC. Okay, and this is a location number for the DC jack, and this point, pin number 5 and 6 is a positive, pin number 1 and 2 is a ground, and pin number 3 is a PSID. This signal is called the PSID. The PSID means the adapter ID signal. Means in the Dell laptop, when we connect adapter to the laptop, then the adapter inform SIO is power wattage, that means how much wattage it is. So it's say all the signal via this line is called the PSID. Here's the signal generated, and this signal is going to the SIO, and SIO read all this information. Okay, so we can see all this detail how this function in another video. So first we understand the way how the battery charging section work. So this pin number 5 and 6 is a positive, it's 19 volt. Okay, and here is a call the plus 19V underscore V in. So here is a that means this page is a page number 82, and the signal start, the voltage start from here and end up at here. So now this wherever you find this plus 19V underscore V in, that means those points are connected to each other. So that is a how to in this way you have to see the connectivity between the signal or between the voltages. So we'll scroll the next page. We'll go to the next page, and you can see here, and we can see here the next page is the battery connector. So this is our battery connector. See, you can see here the battery connectors, and then the battery, this pin number 1, 2, 3 is a ground, then the 4th is a battery present, then the assemblers, and these pins are the positive. Okay, 17.4 volt battery volt. Okay, and these is the SM bus. So this is the battery connectors. So scroll the next page. I'll just zoom out. Okay, I'll just zoom out. So this is my battery charging section. Now you'll ask, how can you come to know whether this is a battery charging section? It's simple. In every page, this is called the index page. In every diagram, there is a corner. At this corner, this corner is a explanation about how what is there on this page, or we can call it the index page. So this corner is called the index page. I'll zoom this page. You can see in this corner, you can see here. So this is the index page. Okay, so this, what is the title is here written, the power underscore charger. Okay, the power charger, that means called the power section or the charger section. And this motherboard made by the Compil, and the model number is LAF 711P. Okay, so in this way we can come to know this page is called the battery charging section. Now we'll see here. So this is my the first MOSFET, this one is my first MOSFET, this one is my second MOSFET, and this connectivity is called the plus V in underscore V in voltage going to here. Now we'll see whether this MOSFET is N channel or the P channel. When I zoom this page, then I will see this MOSFET. This MOSFET location is a PQB11. Okay, this is the location number PQB11, and below that there is a number written called EMB04N03H. This is the number of the for the MOSFET. Okay, so this MOSFET is a N channel MOSFET. You can see here, we can come to know from this symbol, this MOSFET is an N channel because the arrow is inside, so that is why it's an N channel MOSFET. Okay, and this one is my drain and this one is the source. Okay, so 18 volt connected to this pin number 5 to the drain. Okay, and here is a battery charging chips. Here is a battery charging chips, and here is also plus V in 19. So here is also plus V19. You can see plus V19 and plus V19, both pins. So that means the both pin are connected to each other. Plus V19 and plus V19 here also, that means the both pin are connected to each other. That means the 19 volt entered into this diode. This is called the dual diode PD. D means the diode. PDB01 diode. The 19 volt entered into the diode from anode side, come out from the cathode side and pass to via this resistor. This resistor location is a PRB15, and the value of this resistor is, you can see here, the value of this resistor 10 ohm. Okay, and the tolerance is a 1%. So the 19 volt entered into the diode, come out from this cathode, pass to this resistor via 10 ohm resistor, and this 19 volt goes to this chips. This chips location is a PUB01. This is a battery charging chips, and the location is a PUB01, and the chip number is ISL 95522HRZ. Okay, so this one is called the location number and this one is called the chip number. Okay, and to run this chips require power. So the power coming at pin number 17, it's called the DC in pin. So the 19 volt entered into the DC in pin number 17. Okay, so as soon as the chips get the power, chips started working. The another important signal is required, the chip is called the AC in or the AC detect. Okay, so we'll see where it is the AC in or the AC detect. And before that, what you have to check is when the 19 volt entered into the 17 pin, that is the DC in pin, then this chip will generate the 5 volt at pin number 8. Pin number 8, the 5 volt will, the linear voltage will come out at pin number 8. Okay, the next thing is divider circuit. This is a divider circuit. This pin is called AC in pin. This one is called the AC in pin, pin number 16. Okay, and here are these two resistors. this according to the Ohm's law, the voltage is divided here. Here is a 19 volt which is connected to the adapter. You can see here 19 plus underscore V in. These two points are connected to each other. That means the 19 volt is here, and these two resistors are in series. These two resistors are in series. The location number is PRB09 and PRB10. Okay, and the value of this resistor is 347 kilo ohms and the 52 kilo ohms. That means somewhere around 2.6 to 3 volt will generate at the center point, and this 2.6 to 3 volt is entered into this pin number 16, and this signal is called the AC in. When the 3 volt is generated at this AC in pin, that means this chip will come to know that the adapter current is present or the adapter voltage is there. So friends, you have to check this test point number 2. So first thing, you have to check DC in pin number 17, that is a 19 volt. Second thing, you have to check pin number 8 5 volt, and third thing, you have to check AC in 3 volt. Okay, then after that pin number 16, then this is the pin number 24 is called the AC OK signal. This is the input pin and this one is the output pin, AC OK signal. So as soon as the 3 volt entered into this chips, this chip will send out the 3 volt is called the AC OK, and this AC OK signal is going to the SIO. Okay, this SIO OK signal is going to the SIO, informing SIO that the adapter voltage is present, and then SIO started communicating with this battery charging chips via this bus is called the SM bus. Here you can see these two signals is called the SM data and SM clock, and pin number 21 and 22 is called the SDA and SCL, system clock and system data. The two wire communications between the SIO and the battery charging chips. The two chips are communicating with each other, and then after once their communications is completed, then this battery charging chips receive the voltages. The voltage, the 18 voltage which is we are connected to from the adapter, which is halt here, and then what this chip is doing, he just trigger these two MOSFET. Okay, both are the N channel MOSFET, both are the N channel MOSFET, and this battery charging chips trigger this two MOSFET, this MOSFET and this MOSFET. The voltage will come here somewhere around 19 volt. If it is a N channel MOSFET, then the voltage should be around 19 volt, and if it is a P channel MOSFET, then voltage should around 0 to 3 volt. Okay, so you have to remember that. So how you will come to know whether it is N channel or P channel? For that you have to remember the symbol of the MOSFET. Okay, so this is a both MOSFET are N channel. So here supposed to come 19 volt. So once the 19 volt comes to the gate, then the both gate will trigger, and this 19 volt which is come here, which is passed to the source, and from the source it will come here and pass to the this MOSFET. This is called the PQB12 to its source, and then once this voltage will come here, trigger this MOSFET, the voltage will travel via this diode and come here across this resistor. So this resistor is called current sensing resistor, and the value of this resistor is 0.01 ohm. This value is very negligible. It's a below 1 ohm. And what is the use of this resistor? The use of this resistor is simply sense the current, means how much current is passing to the circuit. Just see checking the current. So there are 2 points, this pin number 2 and pin number 4 of this resistor. This 2 point connected to the chips. This is called CSIP and CSIN. These are 2 pins or the current sensing positive and current sensing negative. So once the voltage come across this resistor, some minute voltage drop will be generated at this resistor, which will catch by this resistor, and he calculate the how much current is passing from this resistor. Okay, so that is the use of this resistor. The next thing is this 19 volt come here, and is this is my the output circuit. Wait, I'll show you. Okay, so from here this voltage is passed to the next circuit. This plus 19 volt VB is a system voltage which is entering into the second circuit, that is called a 3 volt and 5 volt section, and there are so many sections. This voltage is sent out to the different buck converter. Okay, understood? Okay, the next thing is, then why you will say why what is the use of this 2 MOSFET? This 2 MOSFET is basically used for the charging circuit to charge the battery. So now this 2 MOSFET connected to the chips. So once when the adapter is connected, then SM bus is started communicating with the SIO, and then if the battery asks the charging, so this is the battery positive connector plus 17.4 battery voltage, then this chip started triggering this 2 MOSFET, switching this 2 MOSFET. The both MOSFET are N channel MOSFET. This both MOSFET are N channel MOSFET, and the 19 voltage which is here started switching and passing via this coil PLB01 and passed to this current sensing resistor here, smoothing by this capacitor and filtered by this capacitor, smoothing by this capacitor, and entered into the battery, and so the battery started charging. Now if your battery is not charging some or the other, then what you have to do is you have to focus on this 2 MOSFET. So you have to check this MOSFET by a multimeter, or sometime what is happen is sometimes the MOSFET shows okay with the multimeter. At that time you have to replace both the MOSFET. You have to get the another working MOSFET and put it here and recheck like that. Okay, so in this way this battery charging section work. The next thing is this one, this MOSFET. This MOSFET is called the discharge MOSFET. What is a discharge MOSFET? The discharge MOSFET means when the adapter voltage is not there, then what will happen? Okay, so when the adapter voltage is not there, then battery voltage pass via this MOSFET. This MOSFET is here is also N channel MOSFET, and this MOSFET is connected to the this battery charging chips. And when the adapter voltage, that means when the AC in, this AC in is a 0 volt, at that time this battery charging chips trigger this MOSFET, then the battery voltage which is 17.4 passes via this resistor, enter to this source, and from the source to the drain, and then it passes to the here junction. It's called the plus 19 volt. So if the adapter is not there, then this section is work, and if the adapter is there, then these two MOSFET are work. So in this way this circuit work. I hope you understand this basic concept of the battery charging section. Thank you very much.